Hello, this is Dr. Kuehn, and this is Introduction to Astronomy at Wisconsin Lutheran College. In our last few lectures, we've been exploring Aristotle's book On the Heavens. We are in Chapter 3 of A Student's Guide to the Great Physics texts. In this lecture, I want to move on to Aristotle's chapters 11 and 12. This is on page 21 and 22 and 23 in A Student's Guide to the Great Physics texts. In Chapter 11, Aristotle asks the question, what is the shape, or rather, what are the shapes of the stars? This is a very short chapter for Aristotle, and he answers this quite quickly. He says that the stars are in the shapes of spheres. Why are they in the shapes of the spheres? Well, he gives two reasons for this. First of all, the stars, because they do not move around, they do not need any appendages to move around. After all, most things that we see moving, like people or animals, have legs or arms or wings to accomplish their motion, but the stars, being fixed to this outer celestial sphere, don't need any kind of appendages to move around, so it would be sensible if they were spheres. You may or may not find this kind of argument reasonable, but nonetheless he presents it as an argument for the sphericity of the stars. Another reason he gives for the sphericity of the stars themselves is by extension from other known objects. So if you look up at the moon, it's apparent that the moon is a sphere. For that matter, the Earth is a sphere. So it seems like spheres are kind of a theme in nature. It would make sense then that the sun and the planets and the stars themselves are spheres as well. Okay, that's a short chapter. Now let's move on to chapter 12. This is perhaps the most interesting and complicated of the chapters in book 2 of his On the Heavens. In this chapter, he looks a little bit more closely at the motion of the moon, the sun, the planets, and the stars. And remember, in our last lecture, we talked about how the motion of these planets, the planets specifically, is quite complicated. Why is it that the motion of the planets is so complicated? Is there a reason behind this? And again, the underlying assumption here is that nature is intelligible. There must be a reason. Even if we don't know it quite yet, there must be a reason behind why things move or act in the way that they do. So Aristotle says that there are two main questions or problems that he is going to address in this chapter. The first, so the main questions that Aristotle addresses in chapter 12 of book 2 of On the Heavens. What are these two questions, or two main problems? The first has to do with whether or not there is a pattern, a discernible pattern, to the motion of the heavenly objects. So let me just give some background here. Remember, in this worldview, the Earth is at the center of this celestial sphere. The celestial sphere, I'll draw out here, it's an enormous celestial sphere, and on this celestial sphere there are stars. Many, many stars, right? And this whole thing is orbiting around or rotating around the Earth about this axis, like this. So the Earth is sitting at the center, the Earth is stationary, right? The stars are fixed to this primary, he would call it the primary sphere, I think is what he refers to it. We might call it the outermost sphere. Right? And they're undergoing, so the Earth is stationary, the stars are fixed to this primary sphere, and the stars are executing the simplest motion, or this primary celestial sphere executes simple motion. That is, it rotates around once per day. This is a very simple kind of motion. In fact, it's the simplest motion of any of these spheres. Well, what about the ones that are closest to the Earth, like the sphere on which the moon is located? Well, this sphere executes a little bit more complicated motion. It rotates around once per day, but the moon also retrogresses, as I mentioned in my previous lecture. It retrogresses through the zodiac over the course of the year. So the nearby sphere, the one on which the moon orbits, executes a bit more complicated motion, or a bit more complex motion, right? So the simplest motion is this big celestial sphere. This one right here executes a bit more complex motion. But what about the planets? Well, the planets are in this region right here between the moon and the sphere of stars. And here is precisely the problem, is that the planets execute very complex motion. Rather, the spheres on which the planets are orbiting execute very complex motion. Now, here is the puzzle. Here's the problem that Aristotle is bringing up. One would think, or one would hope, that there would be some kind of pattern, either from simple to complex, or from complex to simple. So one would hope to see, or one would expect, a discernible pattern. That is, as you go from outside, the farthest out, toward the inside, that is closest to the Earth, you would expect to see a simple to complex progression, you might say. Or perhaps a complex to simple progression, but that's not at all what you see. You see simple motion out here, relatively simple motion in here, and then complex in the middle. So on the contrary, the intermediate region in which the planets are located exhibits the most complicated motion. That is not very nice. Why? Why does this intermediate region exhibit the most complex motion? And in order to answer this kind of question, which is admittedly, Aristotle says, very difficult, we need to understand a little bit more about the just general question of why things in nature move, or why do they change at all. So we're going to digress for a moment to talk about, and this is really how Aristotle approaches this question, how do we understand changes or motion in nature generally? And there are kind of two things that we need to think about here. First of all, the fact is that things do move or act or change in nature so as to achieve an end or a goal or a purpose. Okay, this is the way that Aristotle is thinking about changes in nature generally. So let's think about a few different examples. Maybe this will clarify it. So we have these elements, or the inanimate things in nature like earth, fire, air, and water. But if you want to, you can insert a modern conception like carbon or nitrogen, these kinds of rudimentary building blocks of nature. Aristotle would say that these move so as to achieve their goal, or in his case, the proper place where they belong. Okay, so earth seeks to be at the center of the universe. Air or fire, on the other hand, seek to be away from the center of the universe. They have a goal or a purpose or an end, and their essence or their purpose, their motion, acts so as to achieve that end. But that's not only the case with inanimate things like rocks or water or fire or air, it's also the case for animate things. For example, seeds, when you plant them in the ground, they sprout so as to grow into a tree. Trees act or change in such a way as to acquire nutrients, that is, so that they can flourish and grow. Trees also blossom. They undergo change, they blossom so as to reproduce and make new trees. Animals also undergo changes or motion so as to attain some particular end. So, for example, squirrels will run around gathering nuts. Why do they do this? So that they can grow and flourish and reproduce. You and other people, man generally, reads or studies or listens to physics lectures with a goal in mind so that they might understand nature. These changes or actions or motions are all aimed at achieving a particular end. Notice that some of these things undergo these they act consciously. They're aware of what they're doing as they try to achieve their goal or their end, people and animals. Other ones are unconscious, and yet they still act to achieve an end. So trees are not conscious, at least they don't communicate to us. And Aristotle would say that they're not conscious, they're not sentient beings, and yet they still act so as to achieve certain ends. Likewise, rocks, water, and so on, they're not consciously trying to do things, and yet they do still act in such a way as to achieve an end that is in some sense built into them. They all have a purpose or a goal that is built into them. And so there's this sort of hierarchical understanding of nature that is inherent in Aristotelian thinking. So let me just draw out a diagram here that might help you understand how Aristotle is thinking about these levels of nature. And if you've seen this, I sometimes hit on this in my other physics courses, so if you've seen this before, please forgive me, and if not, I hope this will clarify how Aristotle is thinking about nature. So there are these various levels. I'll call them different kingdoms of nature. Okay, so at the lowest level, you might have things like minerals or plants. Okay, Let me get rid of this right here. Okay, so you have minerals or plants. Minerals or rocks. The next kingdom might be things like plants. The next one might be animals. And the next one would be people or just man generally. Okay, so examples of these. Here would be an example of this lowest level of mineral might be a rock. Okay, what about a plant? Well, an example of that might be a tree. Okay, an animal, I like this one. Let's talk about squirrels. Okay, and a man, a person, maybe a WLC student, Wisconsin Lutheran College student taking an astronomy class. Okay, each of these things has what he would call a form, or you might even ask the question, what is the internal animating principle of these, or the soul of these in a more general sense? Well, the soul, well, rocks don't have an animate soul, they have an inanimate soul, or an inanimate form. We'll call these inanimate. Okay, but nonetheless they have sort of a principle or a form that governs their behavior. Their form is such that they attempt to get to the center of the universe. Okay, trees, they do, according to Aristotle and early medieval thinkers, have a soul, but it's not the same kind of soul as you or I have that goes to heaven. Nonetheless, they have a vegetable soul. Okay, they have some extra something. They're not just inanimate matter. They've got something that gives rise to their behavior that's mysterious. Okay, what about a squirrel? Well, it has what you might call a motive soul. Okay, squirrels have a soul, a property, a form that's different than that of trees. And a WLC student, or more generally man, has a rational soul. Okay, and the properties of these substances are derived from the type of soul or form that they have. Okay, so a rock might have certain properties that derive from the kind of thing that it is. So a rock might be hard. Okay, these are examples. And they might have magnetism. They might be magnetic rocks. They might not be magnetic rocks. Okay, they might have gravity. They might pull things toward them. Okay, so these are kind of more modern notions, but they're derivative of the kind of thing that they are. What about vegetable trees or plants? Well, the vegetable soul gives rise to their ability to grow, to flourish, to reproduce. Those are the properties that arise from what they are. What about animals? They have a motive soul, which means in addition to their ability to grow, flourish, and reproduce, they've got a little bit of something extra. They are sentient. They're conscious. Another way of thinking about it. They're conscious, and they're able to move around in order to accomplish the purposes that they have. Okay? So animals have the properties of this vegetable soul, plus they have the properties of the motive soul. Well, what is a rational soul? Well, it incorporates all of these things that vegetables have: grow, flourish, reproduce, all these things that animal souls have. They're sentient, conscious, and they move, but they also have the ability to contemplate in a way that animals can't. They can reflect. They can use language in a way that animals cannot use language. They can debate or reason in a way that other animals cannot. So there's this hierarchy of nature, 1, 2, 3, 4, and according to Aristotelians and medievals as well, there's a dividing line here between inanimate and animate, but all these would have a soul in some sense. Again, different kinds of souls, nonetheless, they have souls, okay? Now, where are we going with this? Well, all things, they act so as to achieve the goals or purpose for the kind of things that they are. And things are said to be good insofar as they match what they are, or at least what they should be. And they are said to be bad insofar as they are deficient or lack or deprived of something that they should be or have. So let me give you an example. So we might say that a triangle is good insofar as it has 3 straight sides and sharp angles. And it is a bad triangle insofar as it doesn't approximate the ideal essence of a triangle. Maybe it's squiggly, or when you're drawing it, you're shaking, or you have little gaps in it. That would be a bad triangle. But that notion of good and bad doesn't just apply to triangles or mathematical objects. It also applies to everything. So for example, a squirrel is a good squirrel insofar as it does what a squirrel should do. It gathers nuts for winter. It has a tail, and so on. A bad squirrel would be one that is lacking or deprived in some way. So maybe it's missing its tail. That would be a bad squirrel. Or maybe it sits around licking rocks instead of collecting nuts. Insofar as it does that, it would be a bad squirrel. Likewise, a person is a good person insofar as they are what a person should be. That is, having certain virtues, wise, just, courageous, healthy, and so on. In other words, what humans were like before the fall. That would be a good person. And a bad person would be a person who lacks these kind of virtues. That is a post-fall kind of person. Okay. Now, why are we undergoing this digression about purpose and motion and so on? Well, because this is how Aristotle is going to be thinking about the motion of the planets. He says, perhaps we should not be thinking of the planets and the moon and the sun and the spheres on which they're riding as inanimate kind of things. That is, things that are in that first kingdom that we were talking about, the mineral kingdom. Perhaps we should be thinking them more along the lines of animate things like plants or animals. This may sound very strange to your ears, but he said, why would he say this? He says maybe that would help to explain their more complicated motions. After all, just as animals and people undergo very complex motions in order to achieve their diverse ends and goals, so too perhaps these celestial spheres may need to have an animate soul in a sense so as to explain their more complex motions. That is, they're undergoing these complex motions precisely because they have more complex and diverse goals or ends or purposes. So you can see how sort of this understanding that nature has, that Aristotle has of nature and the classification can in a sense explain the sorts of relationships between what they're doing and their purposes or ends. And again, this might sound very strange to you, but what exactly, if you're going to disagree with this, what exactly is wrong with it? We're going to come across these ideas a little bit later when we read, once again, the work of Johannes Kepler, the 16th century German Lutheran philosopher and astronomer, and he is going to go back into Aristotle and try to answer these exact sorts of questions that Aristotle is bringing up here. He's going to ask the question, are the planets animate? Do we need to appeal to an essential nature that is animate in order to understand what planets are doing or why they are? He is going to argue that no, the planets are not in fact animate. We don't need to have a mind or a soul of any sort inside of the planets to account for their complex motion. He agrees their motion is very complicated, but you don't need to, he says, appeal to an animate mind or soul within them in order to account for their motion. He is going to argue that these complex motions of the planets, their motion in, he's going to say, elliptical orbits around the sun, can be accounted for by there being a mind external to them that is imposing a law of physics on them that they're obeying. And this is, in other words, there's a law imposed from the outside on the planets. They're not moving by virtue of their essence or their purpose that is inherent to themselves. By the way, this is really what we're seeing with Aristotle and then later with Kepler, is really a transition between ancient or traditional thinking and a more modern viewpoint. In the ancient and traditional way of thinking about these things, nature had built into it sort of essential powers. And when you saw things moving or acting, it's because of their essence or their nature that was carrying out what they were doing. Okay? In the modern view, nature is in a sense dead or inanimate. And any order that we see within nature is really imposed on it from the outside. Okay? So it's imposed by God, the laws of physics that are imposed upon nature from the outside. And later on, in the more modern period, in fact, as we get into the 19th and 20th century, this order still is recognized to exist, but nature isn't seen as animate, and in many cases, philosophers are rejecting the existence of God, and so nature, in a sense, becomes unintelligible. Where does this order come from? Nobody really knows. Okay? So finally, before I end this lecture, let me talk a little bit more about the final question that Aristotle is going to try to address in this book 12. There's a lot of interesting stuff in book 12. One of the final question he asks is why, this is a different question, why are there so many stars on the outer celestial sphere, but there's only one planet or one moon or one sun on these inner celestial spheres? And the reason he gives, and again, I don't think he's entirely happy with this explanation. Nonetheless, he throws it out as a possible reason, or he provides it as a possible reason. He says it would make sense from a balance or symmetry perspective. The outer sphere, he says, which has a single simple rotary motion, has many stars on it, or many bodies populating that sphere. The inner spheres, which have these very complex motions, have only one body occupying them, either the moon or the sun or the planets. So whereas the outer sphere has a simple motion, it has many bodies, the inner spheres have complex motions and they have one body. So there's kind of a balance that is apparent in nature here. Okay, that is all I want to say about this chapter, and next time we'll talk about chapter 4 in A Student's Guide to the Great Physics Texts.